Have you ever been lost in an unfamiliar city? I mean really lost. No idea where you are, on your own, no money, phone battery dead. I can tell you, it can feel pretty terrifying. I was truly lost in New York once for what felt like a very long time. When I got my head together, I found my way out by using what was around me, collecting observations and using them as clues. Big buildings, place names, subway stations, bridges. I found that I could find the next step by opening my eyes and trusting in clear and rational thought. Well, the same happens with curve sketching. You have to observe carefully, gather the information, and put it on the diagram to draw a complete sketch and get the marks. If you miss the information, you won't have a complete sketch, and you will not get to where you want to be. So this is how not to get lost in curve sketching. This is Think 4. It's a good idea to have a checklist when you're sketching. 1. Can you determine the general shape of the curve from the type of function given? 2. Are there any stationary points? You can find them and determine their nature. Another important clue can be used here. If there's a repeated route, then there is a stationary point at that repeated route, just touching the x-axis. 3. Find the x and y-intercepts of the curve. You should also learn to draw a smooth curve, a single line. It can be a good idea to lightly mark where you want the intercepts and stationary points to be, and then draw a curve roughly going through them with the correct shape. You must then mark the points afterwards. Here is an exam question where you were asked to sketch a curve and had to use clues given. The first bullet point says x plus 4 is a factor of f of x. So you would mark that there is a root at x equals -4. The next bullet says that x equals 2 is a repeated root. So you would mark that the graph will cross the x-axis at 2. And also note to yourself that there would be a stationary point there. Next, if f-2 is 0, then you know there is a stationary point at x equals -2, but you don't know if it is a max or a min yet. Finally, if f-x is greater than 0 when it crosses the x-axis, then you know that the curve is increasing when it crosses the axis. So the curve must have a positive gradient as it passes through x equals -4. Now you have enough information to draw the curve going upwards through x equals -4 to a stationary point at -2 and then down to another stationary point at x equals 2. You could be asked to sketch the graph of a transformed function that's been stretched, translated vertically or horizontally, or reflected in one of the axes. So make sure you learn what each of the transformations do to the curve and the points. Or you might need to sketch the graph of an inverse function by reflecting it in the line y equals x, like this one from 2016. Another common question is sketching the derivative graph. You will use two facts. The stationary points of the curve at x equals 0 and x equals 2 will become the roots of the derivative sketch. And then you'll determine whether the derivative graph is above the x-axis for increasing sections or below the x-axis for decreasing sections. New York is amazing, and yes, I found my way out. It took me about 4 hours, but by gathering the information, thinking clearly, and then taking logical steps, I got out. So start spreading the news. Do the same with curve sketching, and you will find your way to safety too. This was Think 4. Thanks for watching.